All right. So, it's cool. What in the world? Oh, come on. Well,
Is that happening on your screen too?
yeah, that's happening on my screen too. I do, yes.
It's fine here.
It's what?
It's fine here.
It's fine on. Of course, it's fine on there. Yeah. It's like the whole freaking thing. Why the heck is that? Try Adam. See if that helps. Come on. Yeah.
If you just screen share just the VM window, or just the window you're using, that should be an option.
Yeah, I can try that. Oh, man. Okay. It doesn't even show it on for application window. Cool. Come on. All right. Well, this doesn't blink, so just ignore the bottom part of it, and I'll close this out.
Up with the full screen, Adam?
Yeah, I think so. Let's see. Sure. I actually don't want to full screen it because then I also have to compile the files and stuff. Let's see if this works outside of IntelliJ. What in the hell? Has anyone got any ideas on what the hell is going on?
What would class called name?
That's what it's telling me.
Do you have it packaged?
If you already packaged stuff for me.
Oh, well, it's packaged because IntelliJ packages it. Does anyone know how to fix that on the command line?
For running, you just put the package, then done, then whenever your file's going.
Yeah, for that.
Oh, you gotta go back up that book.
So you say and do come. Oh. Oh. It's good working with a bunch of geniuses.
So we can learn the 364.
Okay. All right. Well, sorry about the difficulties there. Oh, yeah. Yeah.
It'll probably take a minute, but-
Looks good. Okay. All right. Well, that'll require some editing, but it's fine. All right. So I just want to go over, like in Java 8, they introduced Lambda syntax and different things that you can do with collections. So I want to go over some of those and just give some examples of what like the power of using them is. So start off with, I'll show you, I just made this simple person object. Person just has first name, last name, age, gender, and gender is just a simple enum, just male or female. And then finally a string of what state they live in. And then different getters and setters for each. And then this this toString method, which just dumps everything about that person. Okay, so let's go back to main. Okay, so just want to show, so like how I learned at first. If you want to use like the built-in Java sorting, the way to do that, you can just create an anonymous inner class. So you can do collections.sort, give it the list, which I just have a list of people, and then create a new comparator person, which has to override the compare method, which takes 2 persons, and then I'm just sorting by last name here. And so if we run that, we'll see if we're just looking at the last names here. We have Susan B. Anthony, Susie Anthony, Billy Bob, all those sorted by their last name. So that works. And then after that, I just have them printed out. But it can be simplified a whole lot more if we use Lambda syntax. So literally all we have to do, instead of creating this new comparator inner class, all we have to do is in parentheses just say person1, person2, and then this arrow. So the parentheses and arrow combination is the Lambda syntax. And then whatever follows is what it'll call. So it's the exact same as doing that. And so instead of having this go to 1, 2, 3, 4, 5, 6 lines, now it's only on one single line. And so then you can just print it out the same way. And so if we go back to the output, we'll see that we got the same exact output. And So I just think that it looks a whole lot cleaner using syntax like that. So for next thing, I want to show you. Oops, not that one. To create this tutorial, I went through just like a sample tutorial on different use cases for it. And so the use case brought up with this example is, say, you have a company that wants to do like automated sending of messages. And you want to have like automated calling, automated mailing, automated emailing. And the examples they gave was being able to call all legal drivers. And they defined legal drivers as anyone whose age is greater than or equal to 16. So whoever has a license. Draftee, as in for like the Army, is any male that is between the ages of 18 and 25 to email them, and then to mail anyone who's legally able to be a commercial pilot, which they defined as anyone between the ages of 23 and 65. So that's just the use case they gave. And so for each of these methods, what we do is we just loop through the list of people, and then we check if their age is greater than or equal to 16. If so, then we do robocall, which in this case, robocall is just a method that prints out the person. So the test I set up for this just creates a new robot, gets a list of people. Then first we print out all the people, and then we call each of those methods separately. So if we take a look at this, here we have all the people, and we have all the legal drivers, and we can see that like Susie Anthony, who's only 10 years old, she didn't end up in this. Draftees, only 2 males between those ages, and then legal pilots. So that's, one way of doing it. The issues with this is if, let's say the requirements for driver's license changes, then we have to go in and change this number or add a new constraint to it. The other issue is that these conditions saying what makes you able to drive, it's not reusable. Like, it's just in this if statement. So if there's somewhere else in our application where we want to use the same logic, we have to duplicate it at this point. So one way, kind of the second way of doing it, is we create separate methods for the conditions. So like, is driver, is draftee, is pilot, and we just pass the person to each of those. And I just extracted the logic out into those methods. And then did it pretty much the exact same test. So if we run that, we get the exact same list. And so this is slightly cleaner because we have the logic extracted out to a separate function. And so therefore, we could reuse it throughout the application in different places. One thing that stinks is that in each of these, let's say we wanted to change it so that we're able to call draftees instead of emailing them. We'd have to create a whole nother function named call draftees, pass a list to it, and it would basically look the exact same as this. So to help with that, we can introduce something called predicates, which are literally, it's one of the things introduced in Java that follows like a functional paradigm. And the rest of the things I'm going to be showing you follow functional programming paradigms. And so literally all a predicate is, it only has one function, the test function, which takes in whatever whatever object you specify. So I specified that it should take in a person object. And so now, instead of specifically saying phone or call drivers, we can just have generic functions called phone contacts, email contacts. And what it'll do is loop through the people in the list, test the passed in predicate, and then if it's true, it'll make a robocall. So if we look at our test method for this, and so we set up the robo, we create our list like we have been, and here we set up our predicates. So we set up all drivers predicate, and this is using the same Lambda syntax. If you have, if you're just like passing in one thing into the predicate function, you don't need the parentheses. You can put parentheses if you want, but they're optional. Then we have the arrow syntax, and then this is literally just the Boolean condition that we used before. We get their age, see if it's greater than or equal to 16. And so this way, these predicate conditions become like so much more reusable than they were before. So literally all we have to do to use it is call robo.phoneContacts, pass in our list, and then pass in our driver's predicate. And we know from looking at the method before, it just loops through the list, calls the predicate.test function, and then when you call predicate.test, it literally just calls, or it runs this Boolean condition on whatever person object you passed in. And so therefore, like I was mentioning before, now we can easily mix and match what actions we want to do. So we can phone contacts and phone the draftees, where before we would have had to create a whole new method to do that. So if we run this, yeah, so just basically the same list of people, and then we can see with the draftees, we emailed them first, and then we called them afterwards, like was shown here. So that cleans up so much better versus what we did in the very first method file. So next thing I want to show you, we go to name test. So this is showing, so before we looked at predicates, and now we're going to look at functions. And so what, and not like the usual function, like, so what a function does, and we can take a look at it here, is it takes in two parameters, and it transforms the first parameter into a type of the second parameter that you specify. So what we're saying by defining this is we're going to pass in a person, and we want whatever this function is to give us back a string. And so if we think of printing out names, what I defined here, like in this casual style, it's just going to be their first name space last name, and then a proper style, which is their last name comma first name. And so what this does is kind of like in our robo methods, is it makes it a lot more generic, so you don't have to specify, create different functions for all these different things that you might want to do. So if we take a look back at our person class, so previously what you would probably do to replicate the same thing is create a method called casual name, method called proper name to do what I did with the functions I define. But instead, what we're going to try is I created this method just called toCustomString. And literally all it's going to do is take in a function, function f, and then functions like this have only one method called apply. So it's going to pass in this instance of the person into that apply method. So if we go back and take a look, how we use that, we can loop through our people and then call system out on person.toCustomString and pass in the style that we want. So instead of having like 10 different printable methods, if you only need to use a certain style like one place in your application, you don't have to make a whole method in your person class in order to maintain that one style. So we just print all the names out in the casual style and then print them all out in the proper style. So if we take a look at that. Yeah, so here we got Joe Smo, Travis uppercut, and then we got Schmo Joe, uppercut Travis. Let's see. And so another kind of neat feature, which I'll bring up again in a little bit, is since we're able to encapsulate these different styles into variables like the casual style and proper style, that means we can also store them in different collection objects. And so we could use a map to store all the different custom styles that we might want to do. So here I just created a hash map, put a key of casual with casual style, proper style. And then just to, so for example, if it's like a command line program, you could have the user enter in what style they want. And so you'd get from standard input whatever they entered, and then look in your hash map, see if that key exists. If it does, then print it out. So just as an example, so I didn't have to do user input, I just stored the keys and then just did a random int for the key. I got the corresponding style and then printed that out. So let me compile it again. Test.
Did you say it?
I must not have. Thank you. Oops. Oops. Okay, so here we can see. So, I mean, wasn't that random. There was only one casual, but I mean, you can see what you could do with it. So let's take a look at, I think this is my last one. Yeah. Okay, so my last kind of list of things I want to show you. Just do pretty much the same thing, get the list, print out all our list of people. And then I just copied that from the previous file. So here I want to show you different methods that they added on to different collection objects. So this first one is the for each method. And so what this does is we can literally just call list.forEach. And here, this will be a person object. And so for each person, we just want to call system.out println with casual name. So this is essentially doing the same thing as this. So instead of doing a for each loop like this, we can instead do it in one line like this. And we can, the reason why I copied over the stuff is we could, instead of doing it the first way, we could use our different styles that we created in the last file. But I'm just going to keep it like this. So I just have like casual name list, proper name list. Let me run that. Yeah, so just does the exact same thing, but it can look a little cleaner sometimes. And so literally you don't have to just use this for printing. You could literally put whatever function you wanted in here. And for each just literally loops through each item, and for each of them calls whatever function you provide at the end of the Lambda syntax here. So next I want to show the filter method. Let's go to here. And so this, what this will do is help us reduce some of the redundancy that we had to do if we go back to our robo lambdas. So what filtering from a collection will do will help reduce having to repeatedly in each of these. We have to create a new for loop, do an if statement. It'll help reduce some of that. So first, I'll show you this search criteria class. It's just a singleton class. And so this is kind of using the hash map concept that I mentioned before. So we're just going to create a hash map with string for keys. Then values are going to be predicates that we defined before. So when we initialize the map, we just create the predicates that we did before and put in the in our hash map. And then there's just a method called getCriteria where you can pass in a predicate name, tries to get it. If it's null, then it prints out that can be found, and then it just exits the program. If it did find it, then it returns the predicate. So let's go back. So now what we can do. So this is just to show kind of what we did before, what we have typically been taught how to do this. So we could get the all pilots predicate by getting it from the search criteria map. Then loop through the list, and for each one, we do all pilots.test. If they are a pilot, then we print out their casual name. But instead of doing it like that, what we're going to do is use the filter method built into this list here. So what you can do, just call list.stream, and then this stream object, what it does is it allows you to, so that the nice thing about this functional programming paradigm is how a lot of these can be chainable. And so what the stream does is gives us an object that you can chain a bunch of different methods on. So we call stream, and then we call this filter. And literally what filter does is it filters out the objects based on whatever predicate you pass in here. And so we do list filter on our all pilots predicate from the search criteria. And then here's the chaining that we can do. So at this point, after this part of it is finished, we'll have just a list of all the pilots. And then for each of those pilots, we'll print out their casual name. And so this does the exact same thing that this block did here. But I kind of prefer this syntax. I think it's a lot cleaner because a lot of times when you see a for loop, and it can have multiple if statements, and sometimes it can be confusing exactly what's going on. But with this, you literally get like a step-by-step on what's going on. You get the stream, you filter, and then you print. That's literally all you're doing. So I'll run this. Okay, so in this filter section, we have just those that are able to be pilots. That's all we got printed out. And so we could do the same thing with a different predicate. Here we could do draftees, but this time use their proper name. So you can kind of see how using the different, the new like collection methods and Lambda syntax, kind of how modular you can make these things. Because I mean, here instead of using that function, we could use the person dot custom toString and pass in any function object we want. You can instead of like for each printing them, we can make a whole new list after we filtered. So if we do list.stream, filter on all pilots, this collect method will return you a new collection. And so if you take a look, this collectors class, it's got several different methods. If I was in IntelliJ, you could see all the different ones. But so yeah, there's toList. There's also toSet. Oops. Yeah, toSet you can call toMap. There's several different ones you can do.
How did they do the mapping?
I don't actually know. I haven't used toMap, but
You probably need to specify like what the key would be and then what the value would.
yeah,
or how
yeah.
you-
I'm sure you probably have to specify like a function that'll grab whatever
in
the
class.
key. Yeah,
Okay.
yeah. I haven't actually played around with that. But yeah, so then what we could do is, now that we have this pilot list, then we could do what we've been doing before, and then just go and print out their casual name. And okay, so now I'm going to move on to the mapping function. And so what what map does So the example is, say we want to loop through our list of people and just calculate what the average age of everyone is. So traditionally, how we would do this is we'd have a sum and a count. We'd loop through. Oh yeah, and I'm getting just filtering by just the pilots here. So we'd use this if statement, increase the sum, increase the count, and then afterwards, we calculate the average and then print it out. So let's do that quick just to see what the numbers are. Okay, so we see the total of the ages is 181, average age is 45 and a quarter. So how we can do this in the new style, though, using all these different methods that we've learned is like this. So to get the total age, we can create the stream object, filter, and then what map does is it transforms whatever object you have here into something else. And so here we say we want to map to an int. And so we transform our person object and return just an int. And so for each person object, if you think of an array, it'll just loop through the array. And for each of those, instead of storing the person object, it'll just replace it with its age. Go through each of that. And then there's literally just a dot sum that we can call, and that returns our total age to us, which we actually don't technically even need because we can also get stream, filter, and then we can map to a double the age, and then there's an average function. And so in this case, we don't technically even need that part since we're just able to have this average. And I haven't looked too much into, so this average function returns an optional double. I didn't look too much into why that is, but just know to get it, if you look down here, to print it out, there's just a method called getAsDouble. Yeah, so let's go ahead, recompile, and run it. And we should see that we get the exact same answer. Oops. Must not have saved it. Just read my mind. Okay, yeah, so we can see we got the exact same numbers there. Yeah, so I think, since we technically only need this block of the code, just comparing that to that there, I think this is like a lot more readable than that is. If you're to just go into a new project, you see this for loop, it's like, okay, well, what are they doing in this if statement? Here we see that we have like a named condition that they're filtering by, map it, and then get the average of it. I think there's just a couple more things. Yeah, and so like we saw before with the stream object, you can also sort a stream object. Before I showed you, you could do collections.sort and then give it a lambda function. But here, so if we stream, we can filter by all draftees. And then if we sort them, we can use the exact same syntax that we used before. We got P1, P2, and then just last name compared to P2's last name. And then for each of those, print them out. And so if you can just think of, I didn't type it out here, but like the traditional iterative way that you would have to do this looks a lot uglier than what this looks like. And lastly, I just wanted to show just like how truly chainable like the different methods are. So it's so chainable that you can filter on like two separate conditions. So if we stream it and then we filter by draftees, and then out of people who are available to be drafted, we filter by who's able to be a pilot. And if we think back to the functions here, so if we first filter by draftee, that gives us 18 to 25 male, and then we filter by pilots. That means we can only have males that are between 23 and 25. And so let me go back. And so what this does is one of the main goals of like the functional paradigm is what's called lazy evaluation. And if you're not familiar with that term, let's go back up to our original calculation up here. So this is what's known as eager evaluation, because we loop through, even though we only want to get the average of pilots, we still have to loop through our entire list just to get at those people that are pilots and then sum and count. But by using these different functions here, we stream it, we filter by those who are draftees, and then, like I said before, after this function's done, we literally just have those persons that are able to be draftees. So in this case, I think there's like, there's only 2 people that are able to be draftees. So then the second time we loop through, we're only looping through a collection of 2 people. And so that's why it's called lazy evaluation, because that way, once you do, if you're doing calculations and stuff towards the bottom, you're not having to loop through the entire list. And the way these are set up, since they're like built straight into Java, they're able to be optimized by the compiler. And so they run fairly fast. So I'll just compile this one more time and run it. Oh, I gotta save it first. Okay, then we can see our sorted draftees. We sorted it by last name. We got Bob and then uppercut. And then if we sort by draftees and then pilots, we see that the only person that's able to do that is Travis uppercut. And so just an example to show, I mean, you can literally keep filtering however many times you want. You can, if there's multiple things you need to sort by, if you want to sort by last name first and then first name for any ties. I could have another sorted after that. And yeah. Yeah, so that's all I got. Do you guys have any questions in the room here?
So there is some sort of optimizations going on. Like,
Yeah.
just looking at it, you'd think like it's gonna loop through everything. Like it's creating a lot of different loops, but
yeah, under the hood, it does a lot of optimizations.
Yeah.
Because it's built like into the JDK.
Okay.
Yeah, it's kind of iffy when you, like, I did some timing stuff here to see if it's faster. Some things are faster using a stream, but other things like calculating the average portion is slower than a typical for loop, but just calculating this sum portion was faster than using a traditional for loop.
Mm-hmm.
So it, and by this being slower, I mean, it wasn't like significantly slower by any means, but
you don't have like a huge data set.
Yeah, I made a different data set of I think it was like 10 million or so.
Oh,
yeah,
10 million people.
Yeah. But yeah, so it can be kind of it's conditional whether it's faster or not. But if faster is what you're going for, then it might not be what you want to do. But if you're looking for like modularity and like code readability, I think it increases it a lot. Any other questions? Okay. All right. Well, we are signing off here.